So the next problem was equilibrium point. It is also simple one. So what exactly they're giving is there is given an array of A of n integers, and equilibrium position is the position where the sum of all integers on its left is equal to sum of all integers on its right in an array. Print the index of the equilibrium position. Note that for any given array, there is a only single equilibrium position. If no equilibrium position is found, then print not found without quotes. And then array is the one based index. So see the constraints. Array must should have more than 2 and less than n size. So array should be more than 2 elements. And assume it is an one based index and array of I not equal to 0. So this is the given one. Let us see the what was given in this particular sample input. They are giving 7 as an input size of an array, and we are taking the 7 elements. But what we want is we want, if you take this element, the left part of the summation of left elements will be equal to the right left will be equal to the right part of the elements. Similar to the next element, there will be one equilibrium point, right? So for the next element, we need to check leftmost summation and rightmost summations. And also for the element 4, leftmost and rightmost. So see the sample output is 4, that means fourth index, and assume it as in one based index, right? So 1, 2, 3, 4. This particular index at 9 element, the output of left, the summation of left part and the summation of right part will be same. See here, -7 plus 2 plus 4 equal to -5. The maybe it is -1 and it will get -1. So that's why the left part and right part will be same at index 4. We need to return the index assuming it as one based index, right? So simple one. We are taking the input size using scanner class. We create an object for the scanner class, and we are taking the element n, number of size of the array from the user input, and also we creating the array which is ARR, and we are taking n number of elements and from the user input and add it to the array of I array of I. So see that element must be greater than two elements. If the element is array's length is 1, uh, it will be not print the not found and return it here. If the element is not an element size is more than 2 elements, we need to do this part of logic. What I did is, before going into the code, I explained it clear. So I will take some sample input as 1. Wait a second. 1, 1, and 2, 2. So first we need to traverse every element of the array. And for this position, the left part is will be remains 0 and right part will be 2 plus 1 plus, that will be 5. And for this element, you get at the second index, assume it as one based index. For second element, we left part will be as 1s and right part will be 4. For this element, the left part will be 2 and right part will be 2. So wherever the left part and right part equal, store that index. This index will be 1, 2, 3. This index will be 3. This is the resultant output. That's what I did it in their core. I hope you understand the logic better. So I just traversed the every element, and I created two, because every what when why I create variables inside the for loop means every time, every time, every time, whenever the iteration change, the leftmost part will be changed. So that's the reason we are creating inside the variables leftmost and rightmost inside the for loop. And in the for this loop, left part means left part means for assume for one, one, two, two. This one, right? This is the I. This is the zero. I want 0 to I. This is the 0 to I. I want summation. 0 to I minus one position. I want summation, right? For right part, I want I plus one to still if there are any elements, I want n minus one. I want this position means I plus one to n minus one. Okay, don't include this part. This will be resultant as output. That is 1, 2, 3. Okay, so we creating I iterating from 0 to less than I, that means I minus 1. We're adding it to the leftmost part array of j. And we're also creating the k from I plus 1. I already told na, from I plus 1 to n minus 1. This is the rightmost, right part, right part, right? So right part. So whenever the leftmost and rightmost are equal, I stored index I plus 1 because I is the one based index, right? That's the reason I is the one. That's why I is I plus 1 here. Okay. If still there is no such situation where the leftmost part is equal to the rightmost part, I remind in the index position it remains minus one because we created it as minus one. So system dot out dot println not found because there is no index like that where the left part is equal to the right part. So else we print the index position. I hope you understand well. Okay, thank you.